Hello everyone and welcome to today's webinar, which we've titled How Can We Bridge the Engineering Skills Gap? Ask Arm Education Media. My name is Rob Sargent and I'm today's moderator. You will have an opportunity to submit questions to today's presenters. You can do this by typing your questions into the questions pane of the control panel, which hopefully you can see on the right side of your display. You may send in your questions at any time during the presentation. We will collect these and address as many as we can during a Q&A session we will have at the end of the presentations. I will now introduce the three speakers we have for today. We've got Dr. Khaled Benkrid, who is the Director of Education and Research at Arm. We've got Professor Alex Dean of North Carolina State University, and Melissa Good, who is the Publishing Editor for Arm Education Media. The format for today's webinar will be as follows. First, we'll have Dr. Benkrid speak on the Bridging the Education Gap, the view from Arm Education. Next will be Professor Dean on writing new curriculum for the next generation of electronic engineers. Then Melissa Good will provide an overview of the Arm Education Media Publishing Program. And then finally, we'll have the Q&A at the end of the session. So first, over to Dr. Benkrid.
Thanks, Rob. Hello, everyone. My name is Khaled Benkrid. I'm Director of Education and Research at Arm Limited, based in Cambridge, UK. And before I start talking about the view of Arm Education on bridging the engineering gap, I'd like to present myself. So previously, before joining Arm in 2013, I was Senior Lecturer, Associate Professor in Electronic Engineering at the University of Edinburgh. Before that, I was Lecturer or Assistant Professor in Computer Science at Queen's University Belfast. And since 2013, I've been leading the worldwide Arm Education Brief, the aim of which is to address the growing skills and education gap in electronics and computer engineering. So this is the vision of Arm Education. Our vision is to play a leading role in plugging the education and skills gap in computer engineering. And our mission is to help academics and students harness state-of-the-art technologies from the Arm ecosystem to allow them to innovate and compete effectively in the modern economy. Our values is that we serve academia and the developer community at large with low-cost, engaging educational materials, tools, and platforms. And we constantly measure our performance based on the requirements of our customers. These are educators, students, and the developer community at large. It's very important for us that we also respect academic freedom. So why are we doing this? The education gap, also known as the skills gap in computer engineering, is growing. This is a reality. The gap is exacerbated by the unprecedented pace of technological changes, which is outpacing the educator's ability to keep up. So what's happening is that there is a growing gap between what students and learners are taught at schools and educational institutions and what industry needs in terms of knowledge and skills. This is particularly acute as educators are struggling to balance teaching with research. Now, this is not an academic problem. Failure to address this gap has serious socioeconomic consequences. The UK Engineering has estimated that failure to address this gap will cost the UK economy £27 billion by 2027. Now, why do we think that Arm is uniquely suited to play a leading role in addressing this gap? It's because we sit at the center of the largest ecosystem in the computer industry. Together with our partners are responsible for a large part of the electronics industry or the computer industry, 70–80% of it. So because of our ecosystem, we believe that we are uniquely positioned to play a leading role in addressing this gap. Now, how do we address this gap? What are our guiding principles? We believe that industry should play a major role, not just as technology provider, but also as content creator and quality assurer. Technology also should sit at the heart of this endeavor. We believe in interactive and media-rich content, in using online delivery and collaborative environment, and we believe in using cutting-edge machine learning and artificial intelligence techniques in order to change the way we teach and the way we learn. Automatic assessment, for example, is a very important element of that, so that we can give feedback to students that is tailored to their needs. Now, the ultimate goal of this endeavor is to achieve what we call accelerated learning. By accelerated learning, we mean that it is a fast learning process that is in sync with the fast changing requirements of the job market. And we believe that this needs to include the custom and dynamic creation of educational content and platform to suit the individual need of the learner. The one-size-fits-all doesn't work. This is a huge endeavor, and we need to work closely together as a community, and that includes industry, universities, and government. And we also need to take a lifelong learning approach here. This is not about addressing this gap at one level, at one step, but it's a lifelong learning pipeline. Now, Arm education consists of two groups. Arm University program, on the left here, basically addresses university needs, and its flagship offer to academia is the education kit, what we use to call the lab in a box, which contains lecture slides, lab manuals, code, software licenses, and hardware provided by our partners. This is free of charge to qualified university professors worldwide and covers a wide range of academic topics in computer science and engineering. Now, Arm Education Media is a digital-first publishing operation that provides self-taught and self-paced online education kits in the form of online courses and e-textbooks. It is available for subscription or purchase to everyone, not just to universities. It is, by design, multimedia rich and highly interactive. So let me say a few words about the Arm University program. As I said, the flagship product of Arm University program is the education kit. This is a self-contained package that's available to professors worldwide, which contains everything they need to teach confidently with Arm-based technologies. It includes teaching materials in the form of lecture notes, lab manuals, demonstration code, and projects. It includes professional software, the same kind of software that students will find in the workplace. It includes also state-of-the-art hardware from our partners. And we top this up by training the trainer through workshops and increasingly webinars, so that we help professors to tailor the content to their individual need. Now, how do we develop our roadmap of content? This is not about us telling the academic community what they need. It's about a two-way street. It's about us, through thought leadership, pushing some kind of new topics to academia, because we think that these are topics that are worth covering, but also it's about us listening to the needs of academia. So it's a push-pull process. Some of it is thought leadership, some of it is demand-driven, and we do listen to our partners in academia, and what they tell us does actually have an impact on our roadmap. As it stands, this is our current roadmap. As you can see, we have finished the creation of 10 education kits starting from 2013. We have developed 2 education kits on efficient embedded system design and rapid embedded system design. And the following year, we developed an education kit on DSP and 2 on SoC design. One is introductory and the second is advanced. In 2015, we developed the IoT education kit in response to the explosion of the IoT technologies. And we also developed an education kit on real-time operating systems. Last year, we developed the graphics and mobile gaming education kit. And this year, we launched 2 education kits so far, one on Linux kernel development, the other on mechatronics and robotics. And we have 2 other kits coming up in the next 12 months, one on computer architecture and one on VLSI design. What is noteworthy here is that there is a built-in update cycle. There is a 4-year beat, which means that every 4 years, we make a major update of these education kits so that they utilize and harness the latest technologies available at the time. This means that our content is dynamic and it rides the wave of technological changes. This is extremely important. So our content is not stale. It has an annual maintenance cycle and a 4-year major revamp cycle. The guiding principles for the design of the education kits are listed here. We believe in hands-on competency-based learning. So although we cover the theory, we also do that through hands-on experimental approach. We believe that it's important to make the material fun and interactive using gaming and multimedia as a vehicle to teach important engineering principles. But we don't do that at the expense of the rigor. So we believe in deep learning. So we cover both the theory and the practice, and we link the two together. And we believe that it's by linking the two together in a hands-on way that actually results in deep learning. We also believe in low cost of access and ownership, and we work very hard with our ecosystem partners to make our tools and platforms as accessible as possible. A lot of them are available. Seed hardware certainly is available free of charge. Software licenses for teaching purposes are also available free of charge. We also believe in convenient access, and we harness the internet for deployment. And we train the educators to help them tailor the materials to their own needs, because one size doesn't fit all. Some educators adopt 100% of our content, some of them adopt a percentage of it, and they tailor it to their own needs. We also believe in reusing the same platforms, hardware or software, for as many courses as possible, thus reducing the cost per course. And as I said, we build in a maintenance and update cycle to keep up with the latest technologies from the Arm ecosystem and beyond. Now, since 2013, we have enjoyed exponential growth, which is testament to the quality of our content, but also to the need out there for such content. There is a huge appetite from academia. Today, our educational materials and technologies are embedded in thousands of classes worldwide. It's truly worldwide. We're constantly updating our content to keep up with the latest technology roadmap, and we continue to listen to the needs of academia and developers worldwide, and what they tell us does have an impact on our roadmap. So we keep revising our roadmap on a regular basis. So let me say a few things about Arm Education Media now. Now, driven by demand from academia actually for content that could be consumed directly by students, plus demand from engineers out there, practicing engineers who want to get access to our education kits, we created a self-taught premium educational products in the form of online courses and textbooks in print and online formats. Now, the roadmap actually mirrors that of the Arm University Program Education Kits, and so far, as far as the online courses are concerned, we produced 5 courses, online courses that are available for subscription today, and this is our roadmap for the rest of the 12 core courses to be finished by 2019. This video, short video, shows you a sample of our latest online course on mobile gaming. So this one teaches students how to build 3D mobile games, and as you can see, it contains lecture materials plus quizzes to allow the learner to test their knowledge and understanding. And it also contains lab videos, which takes the learner through the exact detail of making a professional 3D game. So each course typically contains 10 modules. Each module contains a lecture and a lab and quizzes as well at the end for formative or summative assessment. We top this up with textbooks as well, and we have produced our first textbook only a few months ago. This is the roadmap of the textbooks. And today, in this particular webinar, we're going to talk a little bit more about our first textbook on embedded system fundamentals with the Arm Cortex-M based microcontrollers, which was written by Dr. Alexander Dean. So without further ado, I would like to pass the proverbial microphone to Dr. Dean.
Thank you, Khaled. So it's a pleasure to speak with you all, and I'm excited to tell you about this textbook that I've written recently that plugs in nicely into Arm's vision for bridging the engineering skills gap. So Um, Next slide, please. So my background is I'm an associate professor of electrical and computer engineering at North Carolina State University in Raleigh, North Carolina. And I have been developing and teaching embedded systems courses for many years. These courses include embedded systems fundamentals, so programming a microcontroller in C and using its peripherals, embedded system architectures, describing how to organize the hardware and software, embedded system optimization, how to get the best out of an embedded system, whether it's speed, responsiveness, power or energy, or memory use. So the final course is an advanced embedded systems course that's using embedded Linux and advanced SIMD instructions on Arm Cortex-M series processors. I have had the benefit of quite a bit of industry engagement, so I've done quite a bit of consulting, primarily in the form of doing embedded software design reviews. So this involves studying the source code and design for commercial products, and then going out for site visits to the companies and identifying risks and recommending improvements for their products. I have developed 5 courses for the university programs of 3 different microcontroller or CPU companies. Finally, I also do research in embedded systems, primarily in the areas of compilers, real-time systems, and switching power converters. Next slide, please. So what's difficult about teaching embedded systems? Why is there a skill gap? Well, it boils down to a couple of major problems. First, embedded systems draw upon multiple fields. So computer engineering is one of the foundations. Embedded systems designers need to understand computer organization, but also digital system design, machine code. Electrical engineering is another block of the foundation, in that students need to interface with other circuits, analog circuits, and use test equipment. Finally, computer science is also a fundamental building block. Students need to understand C programming and quite a few aspects of operating systems: prioritization, preemption, task scheduling, task communication, and synchronization, as well as some concepts from compilers and software engineering. So this is tough because we're asking students to essentially triple major in order to do well with embedded systems development. And this is something that very few universities offer, and very few students have the opportunity to triple major. On top of this problem, we have the design space for embedded systems, which is quite a bit different from the general purpose and high performance computers that tend to be the focus of computer engineering and computer science programs. This is mainly due to cost and power constraints. The embedded processors, well, the embedded systems cannot afford expensive power-hungry processors. So there are a variety of consequences that change the design space. For example, in the area of computer architecture, lower CPU clock speeds cut pipeline lengths and reduce memory hierarchies, and instead the embedded microcontrollers rely on the features of peripherals to get a lot of things done concurrently. Similarly, in the field of operating systems, the limited memory and clock speeds cut out the operating system. Linux is far too large for many embedded systems, so instead a different kind of scheduler is used. So the tasks are scheduled using interrupts and possibly a fast and efficient preemptive real-time operating system. So this is my philosophy, my perspective on embedded systems education, and the courses that I've developed and this textbook follow this. So I try to draw just enough information from all of the fields, but not too much. You can see that we span quite a few different fields. So I try to be concise and present what's critical to know. Next slide, please. So one question is, why pick this book? There are many embedded systems textbooks out there. This book is unique. First of all, it directly addresses the challenges I presented on the previous page. Second, it's a companion to the ARM education kit on efficient embedded system design and programming. So that means that it supports the introductory embedded systems course. It targets the Arm Cortex-M microcontroller, which is the dominant architecture for microcontrollers now. It's highly scalable, so Arm Cortex-M processors have clock speeds that can shoot up to a very high level if you need more performance, and that's important. Finally, using ARM provides synergy. If you are a professor that's also doing research on the ARM platform, this plugs right in. If other courses in the curriculum, say computer organization, computer programming, if those target ARM, this course plugs into that and provides synergy. So 3 more reasons that I'll go into detail on are listed next. First, I'd like to think the textbook is easy to read. Second, the textbook covers crucial embedded systems topics guided by my industry experience with quite a few hands-on and face-to-face interviews with industry. Finally, the book uses a hands-on approach with many illustrated examples and source code provided. So a couple of endorsements are put up here. Jack Gansel is one of the gray beards of embedded systems education, embedded systems development, and he really likes the book. So next slide, please. So the first, okay, so here's a brief overview of the book. The table of contents covers generally what you would expect in an embedded systems textbook, but I'll go into more detail on this. The book targets electrical and computer engineering or computer science undergrads with a modest programming background in C and some basic circuit knowledge of digital electronics and little analog electronics. There are exercises at the end of each chapter, and solutions are available to the instructors. The development platform we use is the NXP Freedom KL25Z microcontroller board. It costs a little under $15, and it features a 48 megahertz 32-bit Arm Cortex-M0 Plus CPU in an NXP Kinetis microcontroller. So the CPU runs at up to 48 megahertz. It has 128 kilobytes of flash ROM, 16 kilobytes of RAM, so there's an adequate amount of memory for what we're targeting in this class. Debugging is simplified by the use of an onboard debug microcontroller, and you communicate with that through USB. The board is also powered through USB, so there's only one cable connecting the development board to your PC. And the board has various peripherals, a 3-axis accelerometer, red, green, blue LEDs, capacitive touch slider, and a virtual serial port. And the footprint is compatible with Arduino boards. And this board is embed enabled, so this allows the use of an online development toolchain. Next slide, please. So the first reason to use the book is it's easy to read. I tried to write as little as necessary but no more, so I try to be concise. And I go just deep enough into the critical concepts but no deeper. And I try to present information in a visually appealing way. Next, please. So the text is printed with color highlights, headings. The source code is color-coded with syntax highlighting. There are many diagrams showing timing relationships and software structures. So the idea is to give a visual understanding to the reader of what's going on and not force them to process everything in their heads as text. Next slide, please. Reason number 2, the textbook covers the right material. Here I'm going to talk a little bit more about the table of contents in more detail, and we start off with an introduction talking about embedded systems, why do we have them, how are they built, and we talk about the target platform. And then Chapter 2 dives right into getting hands-on on the processor and using the board to light up lights and read switches. And we look at the world outside the microcontroller as well as inside the microcontroller. And we get an introduction of how to use the general purpose I/O peripherals and program them in C code using the SIMSYS, the Cortex-M software interface standard, which provides hardware abstraction for the peripherals. Chapter 3 then is where this textbook really starts to differ from most other embedded systems textbooks, because I get into the basics of software concurrency. And embedded systems are different from general purpose computers in that they need to provide apparently concurrent execution of many different activities. So sharing the processor is a big part of this. Some of the activities will be done in hardware peripherals, some will be done in software. If the activities are done in software, we need some way of scheduling the CPU's time. So in Chapter 3, I provide a concise single chapter introduction to the concepts of scheduling for embedded systems. And we're going to go into this in, we're going to take a closer look at this in a few slides. But the basic idea is looking at how we can improve the responsiveness of a program. We're using an example program where the flashing pattern of the LEDs depends on which switch is pressed, and there's a delay between pressing the switch and seeing the pattern of light flashing change. This chapter also sets up the textbook, well, this chapter sets up the student to tackle real-time operating systems in a future course. Next slide, please. So Chapter 4 then looks at the CPU core. So we target the Cortex-M0 Plus core and its interrupts. So the first half of the chapter targets the CPU core and its architectures, the programming model, the registers, how to access memory, instructions, and then the second half of the chapter introduces interrupts, and it provides this early introduction to interrupts because they really are essential for developing embedded systems that are responsive. Some textbooks leave interrupts until the very end, and frankly that's doing the students a disservice. So right away we get into the interrupts and discuss the software for interrupts, designing the program. How do we decide what to put in the interrupt service routine and what to leave for mainline code? We also look at how to share data safely given preemption that comes from interrupts. Chapter 5 then discusses using a microcontroller by programming it in C. But the C is compiled down to assembly language or machine language, and that is what the processor actually executes. So in this chapter, we look at the software development tools and then some basics of the C programming language. The students already should have had a language, should have already had some experience in programming in C, but then we look at how functions are made, how to control the program's flow, and how to access data in memory. The reason for presenting this information is that often when debugging embedded systems, you need to look at the assembly code to determine what the processor is really doing, because the C code has been translated into assembly code. Chapter 6 then moves into the first traditional area for embedded systems, discussing the analog interfacing peripherals. So concepts of quantization, sampling, and aliasing, and then examination of the digital to analog and analog to digital converters and the analog comparator on the Kinetis KL25Z microcontroller. Next slide, please. So Chapter 7 then gets into timer peripherals, and it explains the concepts and then discusses some of the timer peripherals on the Kinetis KL25Z microcontroller, including the SysTick timer and the timer PWM module, but also it includes the COP watchdog timer, and this is another fundamental component for embedded systems. This watchdog timer will reset the processor if it isn't periodically reassured by the program that everything is okay. This is essential in all embedded systems. Sometimes this shows up in embedded systems courses and textbooks, sometimes it doesn't. I believe it always should. Chapter 8 discusses serial communications, and it builds on a foundation, first explaining why and how serial communication is performed, and then looking at development tools, specifically protocol analyzers that will decode the messages to simplify debugging. And the third building block is the software structures that we use for communication. Communication is generally asynchronous, which means that messages could arrive at any time, not synchronized with respect to what the program is doing. So we need a way of buffering incoming data as well as outgoing data. So we look at software for this using queues and explain how to make those work, including using interrupts. Then we get into the actual serial communication protocols and peripherals, and we have code with examples covering synchronous serial communication, so SPI, asynchronous serial with a UART, and finally inter-integrated circuit bus, I2C. Next slide, please. Finally, the last chapter, Chapter 9, this covers direct memory access. And this is covered in green because often this is neglected in embedded systems textbooks, but DMA is another fundamental method for getting better concurrency out of a slow microcontroller. A DMA controller allows it allows transfers directly between different memory locations without involving the CPU. So no software needs to execute for these transfers to occur. So this allows the transfers to occur much more quickly and with much more timing precision and without requiring any interrupt service routines. So we can copy data between peripherals or between peripherals and memory. So we can actually get rid of a lot of program operations that would otherwise be necessary. Finally, there's an appendix that discusses how to measure current, power, and energy on the development board. And in this appendix, we introduce the power system architecture, how to measure current and power, well, how to measure current and calculate the power, methods to reduce power, methods to measure energy, and a table chart showing how to modify the circuit to reach these low power goals. So next slide, please. So for this textbook, I think the key differentiator is this understanding of concurrency that embedded systems students need to understand in order to be successful, but it's the most difficult topic. A typical embedded system needs to manage multiple activities. Some of these activities are executed in software on the CPU. Others use hardware peripherals. These different activities will have varied timing requirements. Some things are more critical than others. So our goal is to show these tools and put them in context for goals so that the students have a mental framework for what they can do with this system. So what work can the peripherals do, and how do we share the CPU's time among these software activities and get things done on time? So the textbook tackles this concurrency very early with a tangible hands-on example. I mentioned previously that in Chapter 2 we get right into lighting up LEDs and reading switches, and that's the starting demonstration program. In Chapter 3, we look at how to improve the concurrency of the system so that switch presses are detected more quickly. And then in Chapter 4, we go into interrupts in detail. So next slide, please. So our motivating example is an LED flasher in which the flashing of the red, green, blue LEDs depends on which switches are pressed. And the starter program uses busy wait loops for time delays. And as a result, the program doesn't respond until the blue light turns off, for example. So we might have to wait for a red, green, blue sequence. So we use this simple program as a mechanism for explaining the concepts of concurrency. Next slide, please. So the first thing we do is show the students that it's important to break code into tasks, because that makes it easier to develop code, and it also structures things better so that it's easier to do a good job. And we show the concepts of tasks and inter-task communication. Next slide, please. So we then take the students into the design space and show the CPU overhead on the horizontal axis and the response time on the vertical axis of our starter program. And we see that it uses a lot of CPU overhead doing busy waits, and it's pretty slow in responding. Next, please. So then we show how the sequence of scheduling approaches and using hardware peripherals improves the performance of the system. It reduces response time and reduces CPU overhead in order to come up with a quick, responsive system that meets all the timing requirements. Next slide, please. So, reason number 3, this book has a lot of hands-on examples, and embedded system developers tend to come from the hands-on mindset where they want to build something in order to understand how it works and then modify pieces to really understand the details. So the course material and the textbook contain extensive demonstration code. Driving LEDs with switches introduces GPIO concepts, interrupts, and concurrency. Driving a speaker is used for GPIO. Monitoring an analog voltage for a transition that uses the analog comparator. There's an example of using a thermistor-based thermometer connected to the analog to digital converter to determine the temperature. There's an example of creating an infrared proximity sensor, which uses an analog to digital converter and GPIO. There's an example of using a timer to generate a 1 Hertz tick. There's an example using pulse width modulation to dim an LED. The watchdog timer is demonstrated using a timeout tilt detector that also demonstrates I²C. This board supports a virtual serial communication port with USB. So this gives us hands-on communication with the PC. And finally, there's an example of an analog waveform generator that shows how we can generate an analog voltage using different techniques. And in Chapter 6, we see the basic approach, which uses all of the CPU's time. In Chapter 7, we see how to use a timer and interrupt service routine to get more timing precision. And the utilization of the CPU goes down to 14%. And then finally, in Chapter 9, we see how to add the DMA controller to bring the CPU utilization down to less than 0.5%. So there are many examples. Next slide, please. So I'd like to thank you for listening to this. I'm excited about the book. I think it has a lot of strong cases for why to use it and adopt it. And it targets inexpensive hardware that can easily be expanded. And it plugs right into the Arm Embedded Education Kit course. And finally, here are some links provided that provide more information on the textbook, as well as how to contact Arm Education Media and myself. So thank you very much, and I'll pass it over to Melissa now.
Great, thanks, Alex. Now, before we go into details about the ARM Education Media Publishing Program, I'd like to remind participants to submit their questions for the Q&A that will finish this webinar. Thanks. So I'd like to spend just a few minutes giving you some details about ARM Education Media's publications and how you can access them. Next slide, please. First, we will look at the online courses. We currently have 5 online courses available. You can see them here on this slide. And we have several more on system-on-chip design, real-time operating systems design and programming, and Linux kernel development coming soon. Next slide, please. So the courses are designed to be self-taught, and they're ideal for self-study or for a flipped classroom, as mentioned previously. All the course materials are created with academic rigor in mind and use state-of-the-art technologies from the ARM ecosystem, which covers a vast swathe of the electronics industry. While the currently available online courses address introductory and mid-level courses topics, so freshman, sophomore, junior type level topics, the portfolio is increasingly being updated with more advanced materials. Next slide, please. With ARM as the publisher, you can be assured that the courses will be up to date. While there may be other online courses available, the fact that we are the authors means that our content will always be authoritative and current. So, secure in the knowledge that the online courses are delivering students the fundamentals of the subject area, academics can free up their time to focus on value-added teaching, either supporting a flipped classroom model as mentioned or taking a deeper dive into the materials. Also, using similar underlying technologies, for example hardware platforms, across multiple courses, save customers time and money. For example, our Efficient Embedded Systems course and our IoT course both use the same ST Nucleo board. The courses are available via ARM Education Media's platform provider partners, and details will follow on this, or they can be imported to an institution's VLE, for example, something like Blackboard, Canvas, or Moodle. And institutional and individual access and pricing are available. Next slide, please. So individuals can access the online courses for terms of 3, 6, or 12 months. And prices begin from £70 for a 3-month access. There's a link on this slide to our purchasing portal, and these details will also be circulated again after this webinar finishes. So don't worry about writing it down right this minute. We will be sending this information out later. Next slide, please. We also have access options for academic institutions and corporations. Pricing is based on the number of users, and you can email us for a bespoke quote. Again, these details will be circulated after this webinar. In particular, corporations using company-wide training materials for interns, new starters, or professional development is something that we are very excited about. So now let's take a quick look at our textbooks. Next slide, please, and the next slide. So the ARM Education Media textbook program focuses on combining strong theoretical underpinnings with practical application, again using state-of-the-art technologies from the wider ARM ecosystem. All of our titles feature learning outcome-driven pedagogy with student progress that's measurable via chapter-based exercises and labs. And you'll have seen the sort of how this works in Alex's discussion of his textbook. The textbooks are suitable for adoption for courses in electrical engineering, computer engineering, and related areas. Next slide, please. The textbooks complement the online courses by giving wider coverage of each topic, and they're published in print and ebook formats. Our first textbook is that by Alex Dean, which he has so ably discussed with us. You can see the details of that textbook again here. Next slide, please. In terms of accessing the textbook, if you're based in the US, Canada, the UK, or Australia, and I believe we have all those countries covered in this webinar's attendees, You can purchase the electronic version of the textbook via the VitalSource platform. We are working on an ebook option for the rest of the world. This is sort of cutting-edge ebook development. So if you're not in one of the 4 markets I just mentioned, and you'd like some more information when this becomes available, please just register on our website or email us, and we'll let you know when that option is available. The print book is available globally via Amazon, Barnes & Noble, or pretty much any bookstore that has the facility to order the title for you. And in this day and age, most bookstores are able to order in copies of books that people need if they don't keep them in stock. Next slide, please. For institutions, the textbook is also available for adoptions or library copies in both the e and the print versions. If this is of interest to you, again, please email us and we can work on a quote for you. And the email address you can see on this slide, and again, all this information will be circulated after the webinar. So finally, before the Q&A, and I hope lots of you are tapping away at your questions and sending them in, I'd like to quickly touch on an initiative that we're calling the Arm Education Media Foundation Customer Program. So next slide, please. So as a new publisher, Arm Education Media is keen to establish a strong set of relationships with those institutions who are the early adopters of our courses and textbooks. And to that end, we've set up the Arm Education Media Foundation Customer Program. You can see the benefits on this slide of membership in this program. We're going to have 10 members total in this exclusive group. We'll include your institution's name and relevant promotional and marketing materials that we produce. We'll produce a filmed case study on the implementation of Arm Education Media publications as part of your curriculum. We will automatically consider your institution's relevant faculty members for inclusion in the Arm Education editorial boards. We'll guarantee a 15% discount on all Arm Education Media online courses and textbooks. And we'll give beta trial access to all new Arm Education Media content. So hopefully that will be of interest to some of you listening today, and if so, please email us and we can tell you more. So next slide, please. Yeah, that's it. Thanks for listening. We'd now like to take some questions, so I'll hand back over to Rob for that. Thanks again for listening.
Excellent. Thank you, Melissa. So we are going to now do the Q&A portion of today's webinar. You can still submit questions on the control panel to the right. We have had quite a few in, so we won't be able to get through everything, but we'll try and get through what we can. Okay. So our first question, I believe, is for Professor Dean. In the textbook, do we give concrete uses for each of the examples provided? Yes, we do provide. We do give concrete uses for all of the examples. So there's an example of an infrared proximity sensor which uses an infrared LED that gets switched on and off by a general purpose I/O pin, and there's an infrared phototransistor that looks for a reflection off of some object. And that phototransistor and a resistor are used to create an analog voltage that the A to D converter reads and uses to determine the reflectivity, so the reflection strength. So yes, there are many concrete examples throughout the book. So generally all of the examples are tied in with concrete examples. Excellent, thank you. Our next question is for Khaled. What is the single most important thing that an educator can do to help address the skills gap?
I would say keeping abreast with technological changes and be in direct touch with industry. I think this is very important, is this gap between what industry needs and what academia is basically training a student to be. So I would say keep a very close relationship with what's going in industry, understand their needs and explain to them also your needs.
Excellent, thank you. So the next question is for Professor Dean. It is, do you have any plans for an advanced edition or any further learning editions of your textbook?
Yes, I have plans for 2 follow-on textbooks, one being Embedded System Architectures and the other being Embedded System Optimization. So based on the courses I discussed at the beginning. I'm catching up on other work now that I've finished this one, so it'll take a little time, but yeah, I'm excited about them, and I'm looking forward to writing them.
Excellent. The next question is for Khaled. In the lab exercises that are provided with our education kits, are there any live examples of activities that the student can do to help further their learning?
Do you repeat the question, please?
In the lab exercises with the that are provided with the education kit, are there activities within the lab, rather than it just being a tutorial, are there exercises the student will be completing to further their learning?
Yes, absolutely. This is part of the fundamental DNA of design of our courses, is the availability of this kind of activities to cement the theory that is covered in the lectures.
And I have another question here for Alex. How do you bring your industry experience into your teaching? And do you find that this is beneficial to your students?
Oh boy. I bring the industry experience in many ways, and it's extremely beneficial for the students. I've had a lot of students come back to me after they've graduated and gotten jobs saying, your course is the reason I got my job. Some of the impact that my industry experience has on the course is what I cover in the course. So teaching the students what's important, what they're going to need to understand in order to work in industry, rather than taking it off into a digression of academically interesting topics which are of dubious industrial benefit. So the whole curriculum is guided by that. Another aspect is that I have a lot of war stories that I can tell. Telling students about, well, I was talking to an engineer who does software for water heater controllers, and he said, oh, if you want the students to really have a realistic experience, you should give them 2 weeks to do a project, and then a few days in say, oh no, it's due in 3 days. It's the customer wants it sooner. Changing requirements halfway through, things like that. So there are plenty of war stories about that. So yeah, I have fun bringing those in.
Fantastic. And this next question is for Khaled. Can you tell us a bit more about how you plan to update your online courses?
Yeah, so because Arm Education Media is digital first, actually subscribing to the courses gives you automatic access to updates to these courses. As part of the design of these courses, we have an annual maintenance cycles where we go through small changes, but then every 4 years there will be a major revamp. So for example, if you look at the embedded architecture, the embedded systems education kit, the education kit that we started with in 2013 was targeting the M0 architecture, or V6M architecture, and it's our plan for next year to start targeting the V8M architecture, which is the latest architecture from ARM, which has a lot of features that are tailored to the IoT revolution. So security, for example, using trust zone and cryptocell, etc. So every 4 years, we plan to update the content massively, especially the practical aspect of it, but also obviously the theory that comes with it, so that it basically uses the latest technology, and that if people are subscribed, continue to subscribe, they will have automatic access to those updates, whether they're small updates, the small ticks that are annual, or the 4-year major revamp. This is our contract with our stakeholders or our customers, is that what we provide you is always cutting edge.
Excellent. Thank you, Khaled. I think we've probably got time for 2 or 3 more questions. This next one is also for Khaled. Do you provide a progression map for the learning objectives covered by the ARM curriculum?
So progression map, could we get more information about that? I mean, what?
I'm afraid that's the question as it's come in. I can ask for a bit more. We can take another question in the meantime. So there's another question for Khaled, keeping you quite busy. Where do you see ARM education in 5 years' time?
Yeah, so we believe really in this notion of accelerated learning. And so the ultimate goal, the holy grail for any educator, is to find an economic way to provide tailored teaching and tailored feedback to every student. So we are all different as learners. We don't start from the same point. When we take any course or start reading any textbook, we come with a certain background, and that's different from one person to the other. So to me, as an educator, the key has always been how do we identify the needs of each individual and tailor the teaching methods to suit that particular individual. And obviously, having tutors, one-to-one tutors, etc., in universities that can afford it, and those who can afford it is one way of doing it. But an economical way, in my opinion, would be to harness the power of big data and machine learning and artificial intelligence techniques in order to learn from different behaviors of the learner, especially as they interact with educational materials online, and tailor the content to suit their individual needs. So if you ask me, I would like the ARM Education Media in 5 years' time to be offering custom content that is specific to the needs of each individual, depending on what I would call their learning profile. So investing more into, and we have actually a research project going on this particular topic, on automatic assessment, and how can we infer some interesting information about the learning profile of each individual so that we can tailor the content, the educational content, to suit their own need. So ultimately, this is what it's really tailored, bespoke, customized, dynamic content to each individual.
Okay, thank you, Khaled. I've got one more question for Alex, and I think we may have one further question after that. This question for Alex is regarding the Freedom KL25Z board. That is mentioned that it's for use in the textbook. Are there any other generic learning that could be applied to other hardware boards that you can take from the book?
Yes, good question. So perhaps 2/3 of the textbook is generic. However, the last third is critical for embedded systems, and that is because it targets the peripherals. And the peripherals are generally digital logic circuits that do things such as measure voltages, convert analog voltages to digital, timer, and so forth. These peripherals are different. So NXP makes different peripherals from ST Micro, and the way you access them is different. They have different logic, they have different control registers, they have different settings. So much of building an embedded system is getting the peripherals to work properly. So in this textbook, I specifically targeted one family of microcontrollers, the Kinetis KL family. But generally, the peripherals within the Kinetis family will all work with this textbook. So if you'd like to use this book for a different board, it would be easy to apply it using a different Kinetis microcontroller. Switching to a different microcontroller family would be more difficult and would require porting the peripheral specific aspects of the code and the material.
Excellent, thank you, Alex. We're going to go back to our final question, which will be about the progression map, and then we will have to stop our Q&A session there. So the question was, do you provide a progression map for the learning objectives covered by the ARM curriculum?
Yes, I guess the question is about, the different levels at which we address each topic and what's the roadmap for that, if I understood the question well. So that's a very good question. We start always from introductory to medium level, but we have in our roadmap advanced versions of all of these courses. So we do indeed have advanced learning outcomes that build from the existing introductory to mid-level. As Alex was talking, was talking about advanced topics on optimizations and things like that. And who knows, we might be publishing his next textbook. But we definitely have plans and for advanced topics for advanced learning outcomes based on for each of the education kits that we presented here.
Excellent. Well, I'd just like to thank Khaled, Alex, and Melissa, and thank everyone for attending today's webinar. You will receive a follow-up email within 24 to 48 hours with a link to view the recording of today's webinar. On behalf of ARM and our presenters, thank you for joining us today, and I hope you have a great rest of your day. Thank you.